Good evening. Recording. Okay. So this is not exactly the yesterday. This is another data set, but look at the histogram and stem and leaf. You see, it's the same shape. It's the same shape. So appropriate for continuous variable. The same thing with stem and leaf. But the difference is the stem and leaf. You can actually see the data set, the value of the data. Like for this one now, is a weight of some people that attended antenatal in Ibadan. So the meaning of stem and leaf is that stem, the leaf is the last digit of the variable you are looking at. The leaf is the last digit. The stem or is the initial digit. If there are 3 digits, like for height, now when we say 1.74, there are 3 digits for height, the way we measure it. So the leaf will be the last digit, that 4.04. Whereas the 1.7, the first 2 digits will be the stem. But this one now is weight. It's only two digits, just like yesterday's one, which was age, and there are only 2 digits. So the first digit will be the stem. The last one, the second digit will be the leaf. So the last digit is the leaf. The initial digits, it can be 1, it can be 2, it can be 3, will be the stem. So like for this one now, let me this notation. Like for this one now, 2 here, you see it arranged. If you look, I said that it's the same thing with the histogram. It's only that this one is tilted sideways. It's sitting on the side. It's not sitting on the base. So when you look at the base and the frequency, the first one in the base, these 2 mean there are 2 in that category, and those 2 are 57 and 59. 57, 59. There are 7 in this category, and those 7 are 60, 60, 60, 62, 62, 63, 63. And in this next category, there are 9, and those 9 are 65, 66, 67, 68, 68, 68, 68, 69. Just like that. So you get it. So you can actually pick your paper. If they publish this in journal now, you can actually pick your paper and write the value out, and go and enter into computer and analyze it. Reanalyze it yourself. So when somebody publish with stem and leaf, you have access to the data set for that variable. You have access. Unlike the histogram, you don't have access to the data set yet. That's why stem and leaf, it does the same thing. It gives you the shape like the histogram, but it does more by giving you the data set. So I think it's very clear.
Yeah, it's clearer now.
Okay. So Kayode is clear, right? Dr. Kayode?
Yes, sir. Yes, sir. Yes, sir.
That's great.
Thanks so much, sir.
Okay, you're welcome. So I think any other question? Was anyone with DSA? Because it's very, all those small things, is good to know them so that, because you may think they are small things. When you are now taking critical decision, or maybe you are discussing in journal review, you just off your mind, oh, I think we discussed this in account. So that is why it's good to, not good to overlook little things. Just let's trash it out and agree. So I think if there's no other one, maybe just move straight to today's work. Yes. So we'll be, in this series we have been looking at comparing 2 means, and we have explored the parametric count method test, and we talk about the 3 major types. So the other one, which is where is this student test, is when we get regression. We also use the t-test to evaluate the regression line. So when we get to regression, we look at how that is done. And we now realize that there are many. Somebody asked a question. Please mute yourself. Professor Wakwe, it's like your hand. Maybe you should mute yourself, mute your device, because the noise is coming from your hand. So we now in situations where not all the assumptions of using parametric tests are met. So we have to now resort into either you rely on robustness or use of the parametric test or use an alternative test, non-parametric. But this funniest thing is that these non-parametric, they are very, very, in fact, they are very plenty. They are in different ways. People just start to circumvent. Some are powerful, some are not powerful. So, and Dr. Balogun was raising a question, say he had a median test. So we want to quickly look at, if you look at it, we discuss, you look at the slide, initial slide here, I talk about the parametric test and the non-parametric counterpart. We now say that for one sample T test, we have the Wilkinson sign rank test. There's another one called sign test. No, sign test. Then you just know either sign rank or sign test. For that one sample or pair sample. One sample or pair sample, both of them. It's the same logic. Both one sample or pair sample is sign. You see the sign. So there's sign test. So there is another one they call median, which Dr. Balogun. So what they call median test, those are the only tests, not parametric, that actually make use of median. Somebody raised a question when I was giving lecture on Tuesday or maybe Tuesday or Wednesday or Thursday, was saying that is it not parametric, is it not median you test? So if you look at it, and I told you, look, it's only just one of them that is just median. The rest, you won't see median there. Prof raised a question also, say in the confidence interval, you cannot calculate because this is are not actually most of the time. They don't even use the real value there to calculate. So that's where you cannot. Okay, if you rank something, you now say, will you now begin to say that in the population you are 95% confident that the rank is between? It doesn't make sense. So because this non-parametric, most of the time they are not even dealing with the real data. So that is why you don't calculate. It is only when you are dealing with real data you can say, okay, this is your estimate, and this is you are 95% confident that in the population the estimate will be like this. So you are going to see later, you will see that the drawback of the non-parametric test is that it can, the best it does tell you something significant or not. Yes. So so you cannot estimate this issue of confidence interval. After all, anyway, the confidence interval itself is not a hypothesis test. It's a form of inferential statistics, but it's not hypothesis testing. But if you look at the t-test, all those t-tests, they are close to the confidence interval in the sense that you compare means. When you compare means, the confidence interval is able to estimate the mean and give you the difference between the means, the two means you are comparing, and then give you a range of value in the population which you are 95% confident that you find the difference. But here, all this one is ranking, you just rank. It just give you a ranking and just conclude that it's significant or not significant. That is why, number one, it's difficult to say you are calculating confidence interval here. And the median, what they call median, there are two they call median tests. There's one, this one that talk about this sign test, not sign rank. You want to say just say sign test. It's regarded as a median because it makes it, we're going to use it, we're going to see. It will make use of median, sign test. Anyway, then the another one is independent. We're going to do that also. Is instead of this Wilkinson ransom test, Maguni for 2 independent, even that one can do for 3. That is one thing about that is why it doesn't. That is why it's difficult to just visit that is the one representing 2 independent sample test in the non-parametric. It does not 100% represent it because it can be used for 2 samples. It can be used for 3. So that just show that it's a non-parametric counterpart of independent t-test and ANOVA. That is median. We have, for example, we're going to run with it also. I prepare example to run with it. Those are the different. You see one thing about the non-parametric that even for a particular parametric, you may even begin to have 2 or more non-parametric options, but with different power. So let's quickly look at the first one. Like for this historical background I gave here yesterday, after this man published this one in 1945, Wilkinson, it was in 1947 that man Whitney now further. If you look at the analysis we run, when you calculate you sum the rank, the smaller one is the Wilkinson. So it's the Wilkinson statistic. Man Whitney now took it further. From that, after the summing the rank, he now invented that formula that now calculates the statistic. That is why the Wilkinson and the Man-Whitney, they are together, because some people call it Man-Whitney Wilkinson ransom test, because it's the same process. You first of all get Man-Whitney, you go further. First of all get Wilkinson statistic, you go further to get Man-Whitney, which we did yesterday. And when you run with SPSS, it gives you like that. You see Wilkinson. Then there is a way, especially if the sample size start to increase, you will see Z there. They try to adjust as a formula to feed in the statistics into a formula that will give you a Z, a Z. But whichever way, you see the same. If you look at all of them, either we are talking about Wilkinson, Man-Whitney, and the Z they produce, it's the same p-value. It's the same p-value because it's a process. After you reach a stage, when you rank, you sum. The Wilkinson is the smaller of the two sum. It's the Wilkinson statistic, and the Man-Whitney go further to use the two sample size and the total of the higher total to calculate Man-Whitney. And you can now go further and feed the Man-Whitney into another formula to calculate Z. Especially if you can sample is large to calculate Z. So if you look at it, it's the same thing, back in the same process. They are just the stages. So let's quickly look at this sign test. The one sample Wilkinson test. In a law college, a random sample of 10, I think I have put this thing. Student mark is noted below. Is there evidence that at the 5 different confidence level to suggest that the median mark is greater than 65? Here, you try to compare with a median mark in another college or maybe in the year before. So in the year before, you look at the median mark. Here, and that is why in this one and the median, the one I'm going to describe later, those are the one they call median tests because it makes use of the median. So this one is a sign test. The other one just they call it Moon's median test. So we get there. So the question of Dr. Baulog was asking, median test, it makes use of the median. It's a non-parametric test and makes use of the median. This is, and it's not, we will see. It's not as if maybe make extensive use of the median per se. So look at this test student. These are the number of the students 1 to 10. These are the mark. And we want to compare with a median mark, maybe for previous class. So what you do, as you know, you now look at the difference between, the first thing you do is to look at the difference between the median they give and the mark. Here now, if you look at the difference, you remove 65 for each of these. It gives you 4, 12, minus 27. Of course, 65 is greater than 4. 67 rather is greater than 40. That's why it gives you negative. So this one also is giving you negative. So some will give you positive, some will give you negative. When you minus the median from the test, from the same slide, I think I repeated there. So if you do that, you now rank the difference irrespective of the sign. You rank the difference irrespective of the sign now. So like this one now, if you look at the smallest here is 2, that is why it's number 1. The following is 3, that's number 2. The next is 4, that's number 3. The next is 5, that's number 4. The next is 7. You neglect the side, that's number 5. The next is 8, that's number 6. The next is 9, number 7. The next is 12, number 8. And I think that is then the last one. Okay, number 9, 15, and 27, number 10. That's where you rank them. So after ranking, you now want to know, okay, positive, separate the one that have positive rank from negative rank. The positive rank are this. There are 2 that have negative. Negative rank, that the number 10, that have 27, and number this 5 rank 5, that have -7. This -27, -7. So when you now add, you now add them together, we calculate ignoring the sign, separate the positive and negative rank. You can see that the positive rank, some of the positive rank is 40. When you add all the positive rank, is 40. And when you sum of the rank, some of the negative rank is 15. That's 10 plus 5. The smallest value of them is 15. That is the statistic, test statistic. So there's a formula they just put this say degree. If you look at it now, if the sample size is 10, the degree of freedom will though they didn't just talk about it, just a sample size at the critical level sample size 10, you see the 11. Can you see 11? This one we just did and the sample size is 10. And that's the critical value is 11. It is when the statistics go below that 11 that is significant. So the smallest one is statistic is above the 11. We have talked about this now. That is the only statistic that is becoming smaller, is not significant. So this one now it's not significant. Since the test statistic is greater than the critical value, and we accept the non-approach, so there's no significant evidence that the median rank is greater than 67. So there's no difference in the median rank and 67, in the rank and 67. That's just it. So for this one, the critical value for this sample size of 10 is 11, and we are having statistics that is 15, because it's supposed to be less than that 11 critical value or equal to that critical value before we can say it is significant. So that is how this one is done. And we are going to worry. I didn't just put it here. We'll go step by step. I didn't send it to you unless I can run in, or I can quickly mail it to you now. Let me just quickly mail, because it is expedient for us to practical, to do it ourselves. So when we do it ourselves here, I like someone like Dr. Balogun. It is mainly reach home. Because I think it's another person that behaves like that. This woman, I like the way. The road reach home and go and run it.
Like this.
Hello?
Space, space from one year to another goes to
Please, Dr. Kayode, you are disturbing us. Dr. Kayode, mute yourself. Mute yourself. I will remove, okay. I'll mute you, yeah. So I've muted him. Okay. Let me quickly, just 1 minute, mail the data file to you. Because to me, I want you to have the data file. In 1 minute, I will just mail it now. Please, just give me. If you have questions, you can ask it. satisfaction. I think those are the two. Okay, where is Zoom? I think I've sent it. Someone, you can quickly check your mail. I've sent it now. I just sent a mail. It has no subject, but it's data file. So, Dr. Balogun and Prof, you can download. I know that you will have access to it. You can download. It's two files. So we quickly use the first one, the Mac, so that we see the way it's done with the SPSS. Because sometimes this thing is so dicey. It's very, very dicey. Are we there? If we have downloaded, let me know so that we can.
No.
Have you
downloaded it?
You have downloaded it, right?
Yes.
Okay, that's great. So, okay. You can read it. You can read the mark, the one that is marked. That's the one we are looking at. The mark.
Okay. This is serial number 1 to 10. Mark and median.
Yeah. Yes. Yes, you can share with us. Read it and share with us, sir.
You disable my sharing.
Okay, sorry.
You disable my
because I'm not, that I have not opened it. I have to enable it. Sorry. I have to enable it now. Sorry for that.
Are you see it now?
Yes. Okay. Yes, I can. Yes, we can see it. I see it, yes. So we go to, if you look at it here, you see the way I enter it now. There are two ways. You will be expected to remember when we run the non-sample t-test. You remember that we just go and he give you all his zero somewhere where we can put the value of system. But this one has no that provision. So if you actually want to run it, though there are two ways, but the one that is more straightforward, that 65, you have to, the median, you have to be constant. The reason is very simple, because you are removing it from all of them. I don't know if you understand me now, you are removing from all of them. So it has to be constant. You now, for all of them, just for that median, you now put it there and put 65 down. That's the way to enter it. I don't know if you understand now. So you know the what they give us is 71, 79 up to 75, this 10 mark. They now say that we want to see the median is different from 67. So you are comparing the median of this one from 67. Just like the way you compare the mean with the mean in the population. So in this case now, this median, you now type it as a variable and now put it constantly. You now put that 67 for all of them as a constant. So you now go to analyze now. Analyze, sir. Go to analyze.
I'm in analysis.
Okay, click on it. You click on it. Then non-parametric test. You know it's non-parametric. Dialog box. We now go to two related. Even though it's one sample, you now go to two related. Two related sample. As if it's a pair. The way we did pair sample the other time. You know the way we did pair sample yesterday?
Yeah.
Yeah, two related sample. Yes, you now move. You are using the internet. Stop using the internet. Okay, sorry. There's a break here. Yeah. Now move them. Select both of them. Just select and just move it. So you are removing, it will automatically move the media into the second, as if it's the second variable. You can select both of them together. Click on both of them. Dr. Balogun. Yeah, move the media there. Now click on sign. You can remove with kissing. It's not okay. Just put both of them, baby. Just click on sign. Click on, just put both of them. Click on sign also. Yeah, thank you. Yeah, click OK. Oh wait, you can go to options. Go to option. Okay, you have clicked it. Go to options. Okay. Okay, no problem. Doesn't matter. You will see. Scroll down also, you see. Now, you will see the first one, you know, we have two here now. We have the sign test, and also we have the Wilkinson test. If you look at up, the Wilkinson, yes, you will see the Wilkinson, yes, you will see what did we get there in that we will see 40, 15. Can you see now? That is sum of the rank of, can you see some of the rank of the one that are positive and negative? Can you see positive rank 15, the sum, negative rank 40. Can you see now? Yeah. So when you come here, say positive rank, there are 2, negative rank, there are 8. So what in the Wilkinson rank sum is sum the rank of the positive and negative. The one that have the smallest is the statistic. In this one, there are 8 that are negative. 8 out of the 10, 2 are positive. The smallest also, the one that is smaller is the statistic. I don't know if you understand now. It doesn't really matter which one is smaller. It can turn out to be positive, negative in the positive rank or negative rank that is smaller. It doesn't really matter. But the one that is smallest is the statistic. So for the sign test, the 2 is the statistics, and the p-value you see downstairs. For the Wilkinson sign rank test, The one that the addition is the smallest is the statistics. Are we together? I won't respond now. I want people to respond because
Yes, sir. Yes, sir. We are together.
But is Z that is the final film there?
what is which
Z.
one? C.
Here.
No, the C is not the. I don't know what we mean by the C, sir.
This is test statistics. So they gave the value for the Z and the p-value to when it's two-tailed. This one is
Okay.
rank.
Dr. Balogun, you can stop sharing. Okay, wait. Before you stop sharing, because I don't know why this is. Okay, I can see now. Now, what the prof, you were saying something. You say C is the, which one is C you are talking of?
Yeah, but because this seems to be the statistic now. This is just a rank, but this one is the statistic giving the value for Z and the P, the probability value.
Okay, Z. Okay, Z. Okay. Yes, you are right. And what really happens is that the statistic is the 15, but there's some complex formula now. If they say if the sample size is becoming higher, so they can transform that statistic to Z. The Wilkinson statistic is not Z. It's the smallest. It's the smaller of the value. But you can, I know I told you can change it as the formula did not use to change it to Z. Actually, the statistic is this one. If you look at that table we used the other time, the table we see, for that 10 sample size of 10, the critical value of this is 11. And because this smallest one is more than 11, it's not significant. If it's less than 11, it will be significant. You remember the one we did yesterday? The one we did, we have one that is 4 for Wilkinson, yes, ransom, 4. One is 35, 45 was not significant. The one that is 4 is significant. It shows you that the smaller the more significant it is. It looks somehow, right? It's not a conventional thing. I don't know. Are we getting it? So if you look at this,
Yes.
there are two things we did there. We did Wilkinson, we also did sign test. The sign test also is not significant. The sign test is the one down.
Larry, scroll
down. The sign test, the positive is 2 and the p-value is 0.10 0.109. Yeah, it's not significant. So both the sign test and the Wilkinson sign rank test, they are not. So this sign test is what they, together with another one, the one we're going to do next, is what they call median. They call it median test. They call it median test. Although all of them are, because why they call them median test, we use median here. If we look at what we did yesterday, the Wilkinson ransom and the Wilkinson, yes, the Wilkinson ransom and sign rank. If you look at, we didn't make use of anything. We didn't make use of median. We didn't make use of mean. We didn't make use of either mean or median. You notice there's nothing like mean and median in both of them. But in this one, we use is a median test. This sign test is a median test. Okay, I think we can. You can share. Let's explain the next one. Because to me, it's looking strange to people. What I would advise next, if we have time also, because I'm repeating the same thing next week. So all you that participate here, I want you to, but you are not paying. You're not paying again. Just if you have time, participate. I want you to come and participate also in the next one. But I will not disturb Dr. Balogun to run anything. You hear Dr. Balogun? I'm Prof. I'm Professor Tokidem.
Yeah, thank you.
I will not disturb you to run anything for any group. Because I also discovered that people, when we want to do training like this one, they drag leg. So we actually have more number of people in the second training than the first. I don't know why. The first training, they are fewer. The second training, I say, oh, this is the last one. You will now rush and so the last training are more. So we're going to see. I'm sure Dr. Olagwe will join that one. So I want you to join us though. So that you appreciate it more. You examine that. You also work on the slide more.
Okay.
And you appreciate it more.
Okay.
Because to me, even some of the logic behind it also look somehow. It doesn't look like someone just says the smallest one. You know, a lot of things are there. And at the end of the day, also, there are many of them, they are even more, they are plentier than the parametric tests. They are just different types. Look at this one, and we have the Wilkinson, Saran, Wilkinson, sign, and we also have sign tests for the same thing. So that is just how it is. Look at my Whitney, the Wilkinson together. They also put Z here. The same p-value. You now begin to see, you know, all those things. They are just, they are not as well. I would say it's not as logical as all these parametric. So let's quickly look at this other one. So we have done this one yesterday. Let's look at the median test. The median test is a non-parametric test that is used to test whether two or more, can you see now? Two or more independent groups differ in central tendency. When we say central tendency, we are talking about mean, mode, and median. Those are the measures of central tendency. So whether, specifically whether the group have withdrawn from population with the same median. The principle of the test is that if two samples have the same median, they should have more or less the same proportion of observation above and below that median. What he's saying is that if two groups have the same median, so equal proportion, if you now merge all of them together and now have a common, if they have the same median, if you rank it and send all of them together, it should be the same median. That will be the median, if both of them have the same median. Or the median should not be far from that same median they have. The median of all of them, and equal number of them, each of them should have equal proportion above and below that median, unified median. That's what he's saying. So if they have the same median, they should have equal proportion above and below median. And if that's the case, it should be 50-50 above. Because median is the one that have 50 above, 50% below. This will be true irrespective of the two distribution. You know, this one, either one is Q, one is normal. You know, this issue of median ranking has nothing to do with whether something is normally distributed or not. You have to first of all arrange it in ascending order, look for the middle one. So that's nothing to do with either skewness or not. If any score fall at the value of the combined median, they may either be dropped from the analysis or included with the score less than the median. You're going to see, he's just talking of the logic behind what they just do in this type of analysis, that you look at the score that is above the median, the score that are below the median for analysis. You will see that this median test is actually chi-square. It's chi-square test. It's chi-square test. No alternative to median test when dealing with census data. So this median test is not as powerful as Mann-Whitney U test. It's not as powerful as Mann-Whitney U test, but it's the only one you can use for census data when you talk about survival analysis. You know, in a situation where you do some of this data are missing because the event you expect has not happened. to those people. You know, in survival analysis, what happened, the variable of interest is time before an event. Time before an event occurs. That is the variable of interest in survival analysis. Like maybe all the before the eruption of teeth, the time before. If somebody, they treat somebody for cancer, before relapse, the time before relapse. And that's why they use survival analysis. The survival analysis has nothing to do with whether the person survived the cancer or not. That's not what it means. It's not actually that one. It's talking of time before the relapse. If relapse is the event, if death is the event, it's time before the death. They use it. Even the people that originated are those people that acquire this, people that are doing insurance people. So they want to make sure that it's not people that are close to their grave that come for insurance, because before they pay 1 or 2 years, they die. You just have to pay them lump sum. But they want people that will not die on time, so that they will have paid very well before they die, so that they will have used the money for business, or they have contributed a lot before they say they are giving the person a premium. But someone that just joined yesterday and died today, he has joined, maybe just pay once, they still have to pay the person. So that's why they use that, the survival analysis, time before death. But it's not the death when it says survivor, it's time before an event. It just happened that, okay, death is the event of interest. So the time before that death is the variable of interest there. That's survivor. And because of that, when you're analyzing, it's not all the people that have the event that are happened to them. That's sensor. So in that case, time before event, because the event has not happened before for some people, those one, you will not know the time before the event. These are sensor data. So when you are having sensor data, non-parametric, median test is better, is the only option rather than Mount-Whitney. But apart from that, Mount-Whitney is stronger. So because it has a wider assumption. Okay, let's just continue. No, okay, yes, I think I've just said that. No alternative for this. Let's look at an example now. In the private bank, it is interesting in finding out whether the customer belonging to two groups differ in their satisfaction level. So, current account holder. So you try to see the people that have current account and people that have savings account. Is there any difference in their level of satisfaction? And they use the administrator questionnaire to 2020. They selected 20 from each group. Those one with current account, those with savings account, and try to administer. They now score, put on Likert scale. Maybe the question is up to 20. So aggregate question, when they sum the mark now, these are the aggregate mark for each person. The aggregate score. So we want to see, is there any difference in the score of the people? So it's just like this one now, we can as well use student test. Exam now. But if you just say, okay, maybe it's not normally distributed, let's use, you can use Mount-Whitney U test, or you use median test. Let's see. What I really want to, I will use it. We're going to rerun it with Mount-Whitney. Let's rerun it with different of them. Let's see what will happen. So let's see the way they do the analysis. So this is the rank here. So if you rank them descending, either you rank them ascending or descending, it doesn't really matter. But this one rank descending for all of them, for all the 40. So when you rank it descending, what will happen is that the median score will be between, can you see, this is number 20 and 21. Know something that is 60, 40 rather. The middle one will be 20 and 21. The number 20 and 21 is 62 and 61. So the average of 62 and 60 will be 61.5. So the median for them is 61.5. Now, if you, I think they are put the, okay, going to put that in there. So if you count it now, you will see for group A, the first group, the current, this is not the, if you go back here, you count it, you will see that 8, it's only 8 that have above 61.5 here, and 12 in savings has above 61.5. So look at the table now. It will give you a cross tabulation. Above median, 8 of them. Below grand median is 12. Above for savings, grand median is 12. Below is 8. It's 2, it form 2 by 2. The statistic for median test is chi-square. Is a statistic for their median test. This month median test, the statistic is chi-square. So the issue there is that it's just the median you use to divide it. That's what they call the median. It's the median you use to divide into above and below median value. So this is 2 by 2 table. If let's say we are comparing 3 categories, now I told you also for man with you, that's what it will give you 2 by 6 table. If let's say there are 3 categories, maybe we have, like for this one now, current, savings, and corporate or domiciliary account, we just put like that. If let's say we have something like that we have 3 or 4 categories, so we're going to have maybe 2 by 3 contingent or 2 by 4 contingency table. So it end up leading you to chi-square. That is what this median test does. It leads you to chi-square because the statistics actually care chi-square. So look at it now. So if you do our chi-square, as we know, if we run it, we will calculate the chi-square. The chi-square for this table, the way we usually calculate our Pearson chi-square is 1.6, and the year corrected chi-square is 0.9. And you know the degree of freedom is 1. Can you see? Because it's the same thing, root minus 1 times square minus 1 total, the way you do the contingency table. And the critical value is 3.844. That shows that the chi-square, the p-value is greater than 0.05. It's not significant. There's no significant difference in the satisfaction between these two. Those people that have current and savings account. Now let's see the way we run it. Let me stop sharing. So who will run it for us? Can Prof run it for us since Dr. Balogun run this the other one? This one is the, you see, satisfaction with bank account, something like that. The bank services. The other file, satisfaction with bank services. Somebody should share. Satisfaction, bank services.
Can I share, sir?
Go on, sir.
Oh, my network.
The network.
Okay, I think it's okay now.
Okay, just a minute. Just a minute. I'm checking something. Okay. Oh. Okay, yes. Okay, we go to analyze, even though it's not sure. Okay. Analyze. We are not seeing it, right?
I think I can't see it. Yeah.
Because it's not coming out very. I think it's your. Maybe stop sharing and share again. Or go and share second share the same thing. Listen.
I think there's a problem. So.
Okay, maybe Dr. Balogun should share it so.
Second pair of data.
What do you say? What do you say?
Are we sharing the second pair of data?
Yes, satisfaction. Yes, satisfaction.
Okay.
Yes. That satisfaction with you have to click and.
Can you see it? Can you see it?
I've seen it, but you have not clicked on it. You have to click on it in SPSS to open it. You have to open satisfaction with.
It has opened.
Yes, that's open. Yeah. So you will see that is for two group independent group. That's why they are enter in series. No, we keep on saying it. After the current account, you go down. Number 1 to 20 is the current account holder. Number 21 to 40 is the savings account holder. And these are the satisfaction, the level of satisfaction, and the satisfaction score. So let's go now. This thing also we can run. Okay, let's just do what we want to do. And analyze.
Okay.
No. You know, it's not. You go to 2K independent sample, K independent sample. Yeah.
Sir, why did you go for that K independent, sir?
Okay. You know, I told you that this median test, it can be for 2, 3, 4 group. It's not for 2 sample alone. Does it make sense? It's a non-parametric counterpart for both independent t-test or ANOVA. So the is somebody
ANOVA.
It's not ANOVA, but it's also a non-parametric counterpart for ANOVA. Though Kuka-Wallis, one way ANOVA is a non-parametric. This also is a non-parametric counterpart. You know, as I've told you, these non-parametric, there are plenty. So sometimes they are plenty the same thing, but you can reduce it here. So I don't know if you understand me now. So you know the way if you go to the lab, you won't be able to run the analysis. It will not run what they are running. You will see not see median as an option there. You will get the picture now. So you see what will happen. Now put test variable is satisfaction. No, satisfaction. Group variable is account type. Why is it not moving? Account type. Move it to that group variable now. The arrow is down, yes. You see, it says define range. It didn't say define group because sometimes the range can be more than 2. Yeah, click on define range. Then you now put minimum is 1.
Can you see it?
I can see. Minimum is 1, maximum is 2. So in case there are 3 groups, I will say maximum is 3. Can you see? Maximum is 2. Continue. Yeah, click on median. He by default he click on Kuka-Wallis. Click on median also. Please, okay. Yes.
Hello, sir. I thought you said this is not Kuka-Wallis.
Yeah, it's that was the first option.
Thank you. He's not following. The first, I just said you should leave it. You can as well uncheck it, but it's just there. It by default. The computer, that's the commonest one people want to do there. That's the commonest non-parametric counterpart. You get the picture. They want to do.
Okay, sir.
But if you look at the median, what we want to do is median. But since both of them, let's see the result of both of them if it's comparable. That's what I'm saying. Okay. The median. You will see chi-square. You see the chi-square?
Yes, sir.
And you also see the still p-value there. It will tell you that current this, it will tell you 8 satisfaction. Median for this current, median is greater than 8 of them are greater than median. 12 are less than median. In greater than median for savings. Like this. Less than, that's all, if you count it, that's what you see it there. Oh, you have on share. Let's look at the Kuka-Wallis. Let's see what it's giving us. If share back, Dr. Balogun. I just remember something I want to give you now. I want to give you one practice file, another one. Let me give you, I have something I use for ANOVA, 3 groups, so that we can run that, the same thing with the 3 groups. So you can see the way different. Presentation. Just 1 minute, which I start. Viagra. Yes. Dr. Balogun, share that thing back now. Let's look at that Kuka-Wallis value. Hello? If you are not talking, if you didn't, unmute yourself.
Hi.
Yes, I say share back that thing.
Okay.
Yeah. Yes. Yes, let's look at the value. We can see the chi-square. We can see there's no difference between the 2 groups. Let's see the chi-square. And let's see the, let's see the Kuka-Wallis up. No, the chi-square is what we get, and this Kuka-Wallis chi-square. If you look at it, their own Kuka-Wallis also is chi-square. You can see that the chi-square is different, but it's not significant also. Because the way he's doing this one is doing ranking. Yes, I mean now. But this one look at the difference between this thing. Okay, let's. I'm feeling hot. Okay, any question on this? Any question on this? You can stop sharing. You can stop sharing, sir. Any question? Any question on this? Any question? Okay, I want us.
Well, what I wanted to, I think I'm more familiar with Kruskawali's
Okay.
in literature than a median test. So,
But the Kukawali is not actually for to compare two means. So that's why you don't get a, by default, the computer just give you better. The Kukawali is for when you are comparing 3, 4, 5, is the non-parametric counterpart of ANOVA, one-way ANOVA.
More than two.
More than two groups, yes. But this median test is for 2 or 3 or 4. Whether it's 2, it's non-parametric also. You can use it for as a non-parametric counterpart of independent t-test or one-way ANOVA. I don't know if you understand now. So the median test. So, but we just run it for 2. I have a data I just sent now. You can download it, or maybe I should run it myself. Is the data I use on ANOVA on its own. It's for ANOVA. So it has 3 groups. We can try and run it now and run this median test to see and compare with the result of ANOVA there. Yes or no? Because after all, even the ANOVA, you cannot use ANOVA for, sorry, you cannot use to compare with Kukawalis. You are not supposed to use Kukawali for 2 groups. You use Kukawali for 3 or 4 groups. Just like the way you can, but you can use median for 2 groups, you can use for 3 or 4 groups. I don't know if you understand now. Maybe I should share my own and run it because should I or have you? Can I wait for you to download? I just send it to everybody also. It's one Viagra.
Yeah, let's see how your ANOVA and Kukawali to compare.
Please go ahead. Run the set you have.
Okay. So let me read it here. Okay. No, it's not. This is not what I want to share. It's not this one. Let me just go and open it now.
Please go ahead. We're having difficulty.
I'm going. I'm looking for the. I'm going to the where the something is. Yes, this is something. So, can you see now? This is libido score among 50 people, but in their 3 group. Low dose placebo, and please placebo. The first group is placebo group. The second group is low dose group. The third group is high dose group. And these are their libido. So there are 3 groups now. So go to analyze, non-parametric, legacy, K-related sample, and K-independent sample rather. K-independent sample. So libido is the test. The group variable is
the old slide
what do you say? Reduce the volume. Your speaker is not really, we are not hearing you.
Media you are sharing it is the old file you are sharing for 2 groups, not 3.
No,
Mark
okay.
and median. Mark and median.
Okay, wait.
That's what I'm seeing.
Don't worry, if that's the case, don't worry. I will reshare. No, I'm coming. Don't worry. Okay. Maybe I should. But okay, no problem. Which one is this libido? Look at it. Can you see it now? Can you see? Libido. Can you see?
Yeah.
Yes, sir.
Yes. If you remember Professor Kokidem, when I came to Calabar, I used this file. That's why you used to demonstrate ANOVA.
Yes, sir.
You can,
I
okay.
remember.
Okay.
Yeah.
So now you will see, we just go to analyze. You see 3 groups: placebo, low dose, high dose, and this is the libido. So we want to see non-parametric, K independent. Now libido, move it here. Dose is the group variable. Give you defined range 1 to 3 because you coded 1 to 3. Look at it now. Median, Kuka-Wallis. You click. So look at it. Kuka-Wallis is significant. Can you see? And median is not significant with median. Where we are
I'm not seeing the output.
Oh, so sorry. I need to share the output. Sorry.
I'm not seeing the output.
Sorry, I will share. I have to reshare it. Don't worry.
New screen sharing.
No, I'm not seeing the output.
Can you see it now? Can you see the output now? I've shared the output now. Okay. Can you see the output
Not
now?
yet.
Yes, yes.
Yes, okay.
Okay, yes.
Yes, now it's now showing. Yes.
So the Kuka-Wallis, you see, if you give you you rank them, mean rank whatever, it now give you chi-square because even the Kuka-Wallis also is chi-square. You know, I've said it before. Even the Kuka-Wallis test is chi-square. Most of these non-parametric tests, most of them are chi-square. And the funniest thing is that the logic of the chi-square is better than the others. Yes, I mean the logic. If you look at the one you just explained now, the logic is very. All those other we can see. You just rank down. That's the smallest one. So because how did they fabricate it from there? The logic of the chi-square is a fundamental one, so it's easy to understand. So this is we can see, and you can see that there's a difference because the p-value is 0.45.
Kuka-Wallis.
Yeah, but the median. Look at the median. Can you see? The chi-square is the degree of freedom here is 2. Let's see the other one. Even the this also the degree of freedom is 2. For Kuka-Wallis, the significant, but for this one, the degree of freedom is 2, but the chi-square is 3.752. It's not even significant with it will not even be significant with the degree of freedom of 1. Because the critical value for the graph is 3.484. It will not even be significant with the degree of freedom of 1 or 2. So it's not significant with median test. So you can see now the median test is not as sensitive. And this thing, if you run it with ANOVA, is significant. If you run it with ANOVA, this thing I will go and run it, you see. It's significant with ANOVA. So you can see that the median test is not so sensitive. And they already said it doesn't have good power. That's median test. It's not as powerful as the other Mann-Whitney, all those other ones. There's only that if there's sensor data, that's the one you can use. That's just it. So let me just unshare or let me go and run. Let's run ANOVA with this data because it's actually designed for ANOVA. Something is for ANOVA. Actually used to demonstrate ANOVA. Compare means one way ANOVA. That's how to run. When you get ANOVA, that's how to run ANOVA. The video, the same logic. Factor. That one. You don't need to say group. You already put it because I've already labeled the password 1, 2, 3. That's why if I didn't label those factor 1, 2, 3, it will not even appear.
Sorry.
Yes? I'm listening, sir.
Okay, I was just wondering, you were saying that
we cannot hear you. We can't hear you.
the median test is not powerful enough.
It's not as powerful as my Whitney U test.
Yes, he says it's not as the Kukawali. I'm saying, it's inappropriate to use in that scenario. Because we are not just looking for what is significant,
No.
but what is appropriate.
It's not inappropriate, but it's not powerful. It's not powerful. If you look at it, see, it's appropriate because they say you can use it for 2 groups, 3 groups, 4 groups. We are using it for 3 groups.
It's appropriate.
But it's not appropriate because, well, I can say it's not appropriate in this sense because that thing is good, even something is good for ANOVA. Well, the sample size is very small. You cannot say it's not appropriate, but it's not powerful. It's appropriate because Kukawali is significant. If you do this thing with ANOVA, it's significant. With Kukawali, is significant. It's the median test that is not significant. It has less power. I think I said in one of the last slides. It has less power. It's not as powerful as number one, the parametric tests, they are not as powerful as the non-parametric tests. They are not as powerful as they are not as powerful. Let's run this one, you see. This is ANOVA now. You see the p-value? The p-value is 0.025. For Kukawali, 0.045. So it's more significant with ANOVA. And the median test is not even significant. We see. So what we can do is, let me just unshare. You can share the other one. Let's run them. Let's run that last one, Dr. Balogun. That last one you did for the median. Let's use students independent T. Let's see the result it will give us. But sometimes when you do both of them, they give you the same.
You are still sharing. Yes.
I want Doc. No, I'm not. I've stopped sharing you. I've stopped sharing. Let Dr. Balogun share it. So. Dr. Balogun. Okay, it's like Dr. Balogun is out too. It's out too. The connection is out. Prof, do you have? You can share your own, sir. Prof. Professor Etokidem.
Which one, sir?
Let's share that satisfaction, bank satisfaction. Satisfaction with bank satisfaction. If we share that, let's start.
Okay. Okay.
Etokidem.
Yes, I'm trying to share it, sir.
Okay, sir.
Bank satisfaction. I don't know what the problem is. It has shared, but I will find all those analyze and stuff like that.
Okay, I understand. It's
a systematic error.
Stop. I have to go and buy it. Let me just finish.
I can't type.
Okay, don't worry. Let me share my own. Just hold on.
Okay. Oh, I've already removed.
Let me just discard this before. Hello? Let me share my own. Let me share the same file. Let me go and read it because let me share my own. Come back. Okay. Yes, okay. Let me. Have you seen it? Did you see it? Account type.
Yes.
Can you see? You can see it. Okay.
Yes.
Okay. So we just do the normal.
That's the libido one. Oh.
No, is it the video you are seeing? Okay.
Yes.
Don't worry. Don't worry. I will reach this one. Vic. Can you see now? Account type satisfaction. Can you see? Can you see it?
Yes, sir, we can see.
Yes.
Okay. So just do the student T. Analyze, compare means. Independent T. Prof, your this thing, your hand. Oh, it's
Oh, it's showing. Oh.
eh? Who is making noise? Okay, satisfaction. Enter. Internet is. Then group, account type, 1, 2. Let me share the results. Can you see the result now? Yeah, it's not statistically significant also. Look at the T. Look at the P value. It's not statistically significant also. Yeah. You will see. And the variants are not different because if you look at the 11 tests, the variants are comparable. Can we see? If you don't unmute yourself, I cannot hear you. Can everybody see?
Yes, sir, we can see.
Yes.
We can see, sir.
Yeah, you can see.
We can see, sir.
You can see that it's not significant also. Which there are sometimes both of them will not be significant with either parametric or non-parametric. So that's the situation we have found ourselves here. So you can see that all those data sets we use, even the other one, we use, we can actually perform. Okay, let me use that one. Is depression. Let me use that depression also, depression scale. How many of them work here? Okay, this one that we use for this one we use for this thing. Let me share another one. All those other one we have done. Okay, this is the one we just did now. Let me share another one. Okay, no, this is another. Maybe I just close them. Let me close the one I'm not using. Yes, through this. This is median. Let me use this one. Okay. Coming, I want to. Yes.
You want to run it first.
Yes, I want to run. Let me share one now. Okay, this is the one we used for median. The first one we did, sign test. Let's assume that even the one they call median, let's assume that it is the mean 67. If we want to run it, just say compare mean, one sample t-test. This is the mark. Then we are comparing with 67. Okay. Look at it. Just like the other one, so it's not significant. This one is not significant also. Look at the T. The T is 0.634. Though it appears that the T is easy for you to run because they have done the program. So you see, look at the T. And look at the confidence interval. So it crossed 0. So it cannot be significant.
Sorry, I can't see the output. I can't see the output.
Okay, sorry, maybe I didn't.
Yeah, they are still working on it.
No, I've run the output.
No, he has run it now, but
We have not seen it though.
Have you seen it
no,
now?
I've not seen the output.
I've shared it now. You have not seen it yet.
No,
We have not seen it.
We are not seeing the output.
Don't worry.
No,
Okay,
not
we
the
have seen it now. We have seen it now.
You have seen it now.
Yes, sir.
Okay, when I remove it. Okay, that's great. This is the output for assuming instead of you doing, you want to do a parametric test with that data set. So you assume that maybe that 67 is the mean also, the mean in population. So this is the median. That's why you use not parametric. It's not significant also. So it's the same thing. So the one I want to read again, let me go and read the one we have done before, the one we did yesterday, the depression scale. Let me go and read that one, and we run it also with parametric. So if you do that, we can run all those other we did with mean also. We can run it with non-parametric to see.
Counterpart.
Yeah, counterpart. But let me first of all do this. I'm feeling hot. Are you not feeling hot? Okay, the fan, Abby. Okay, no problem. You want to even want the fan. Can you see? Okay. I don't know if anything they have seen it. Can you see it? Can you see now? Can you see the Bex, the depression stuff? Can you see?
Yes, sir.
Yes.
Yes,
So
sir.
Yes, sir.
let's use normal student instead of parametric and not parametric. Let's use our parametric. So we go to explore, compare means, independent sample. So depression, you can put both Wednesday and Sunday. Substance use, drug. The 2 is alcohol. So let me share the output. Can you see the output now?
No. Oh, yes.
You have seen the output. I have shared the output. You have not seen it?
It's visible.
Yeah. You noticed yesterday that the between drug and one is significant, one was not significant. Between drug and alcohol, it was significant on Wednesday. It was not significant on Sunday. You remember? Hello?
Yes.
Yeah. If you look at it now, it's significant. The Wednesday's is significant. You see, it's significant. Look at the T. Look at the P value. Look at confidence interval. Tap for plus and hand as plus. For the Sunday, somebody is making noise. Don't know. The person will have muted the person. So look at it. Look at the equal variance. Look at the Sunday. It's not significant. Look at the T, 1.449, and look at the confidence interval from minus to plus. It's not significant on Wednesday, but it's significant on. It's not significant on Sunday, but it's significant on Wednesday. That's just logic. So another one. Let's now run the pair T test. You know, we use this.
I have a question, sir.
Okay, sir. Okay,
I have
sir.
a question, sir.
Yes, sir.
So using a T-test here, I don't know the scale. Is it the scale used in measuring this depression? It's not in I think it's categorical and not.
Yeah,
it's ordinal.
Yeah, it's categorical.
Very correct.
Let me just learn. It's categorical. It's going to be a Likert scale. It's ordinal, categorical ordinal. But it's not the individual something there. It's an aggregate score. Maybe they have about 20 questions. Before they now have arrive at this aggregate score, they might have added the score from each question. I don't know if you understand me now.
Yes, sir.
So you can as well use it. It's just like when you do this knowledge as you practice that people do. The knowledge question, most of them are yes or no, yes. You give the score, you give the score, you give the score. You now go and add the total score together and now put whatever anybody score over the total possible. So if you look at it, you now express it as percentage. And you see calculate the mean. Because at that level, it is believed that you can follow normal distribution. We have already said that it's not the robust test, T-test is a robust test. It's not strictly that all the conditions must be fulfilled. I don't know if you understand me, because it's not the individual score we are looking at here, it's the aggregate score now. After they have done the depression or something, it's aggregate score.
Okay, sir. Thank you.
Yes, but the only thing that can work against it is the sample size, because it's 10-10. 10-10. Can you see? So it's the sample size. So the samples can work again. But what I'm just saying, if you look at it, both of them, they give the same answer. They give almost the same answer. It's on few occasions that you have different something. So just to confirm that they give the same answer. Okay.
All right. Thank you, sir.
Yeah, welcome, sir. Let's see. You know, there's one aspect that's independent yesterday, which we just run now. The aspect which is between Wednesday, the one that is independent is between drug and alcohol. We just run student teachers now. But the aspect, the other one, which is the pair between Wednesday and Sunday, we can use pair t-test also. Let me try that. Compare mean, pair sample T. We now move. Okay, no, I have to first of all, because there are differently for drug and for alcohol, I have to split it. Otherwise, it will give you a wrong something. You know, you remember when you were running yesterday, you split it before you could do it. What do you say?
Can you unshare this output first?
No, I'm going through it's even, you can access it from the output also, because all those icon and especially is both there, is there. I just want to access the output through the icon.
Okay.
Yes. Data,
Okay.
under data, you can go and split. It's the same. Even whether you are there or there, here, it's the same. Under data,
Okay.
go to split.
Split.
And when you get to split, they compare groups. You now move the group variable here. So whatever you do now, it will do it separately for the drug and for alcohol. So let me go for it now. Compare means pair sample T. We now move them. Say okay. You can see the output now down. You can see the output down.
Yes.
Yes. I think was any of them significant yesterday? Yes, both of them even here are now significant. Between Saturday, between Sunday and Wednesday, the result here, both of them are significant. And if you look at it, it's like one was not significant yesterday. Hello?
Yes, yes. I don't remember the result myself.
I think it was the difference was significant for, oh, was it? We can run it to know what was the outcome. But it's on the slide, yeah? It's on the slide. Let me check it. Let me check it. Let me check the slide. The result yesterday. What is here? I think it was only drug that was significant. Alcohol was not significant.
I don't remember the result.
Okay, both of them were significant. Yeah, both of them were significant. Both of them, they were significant. The difference between Sunday and Wednesday, it was significant for both drug and alcohol. There is little like it was more significant in drug, and the same thing now. Drug, it was 0.012, alcohol is 0.047. So if you look at what we have now, it's the same. The same thing. It's the same thing. I think we get it now. Any question on it? Any question? Before I try to even use some of those ones we use for parametric tests, before I now use it to even use run it with non-parametric. Any question in this sense? Well, Dr. Larry is back. Dr. Larry, you logged us before.
It's a network. Can you hear me?
I can hear you, sir.
Okay. I'm just wondering, you are making a distinction between the individual question and the aggregate, that when you get the aggregate, that you can actually use the parametric, because
this
is but was ordinary of use the parametric is not too clear. It looks like some people are too puristic now, even though the aggregate comes up to some. Nevertheless, the original measurement was ordinary, which we seem to be inappropriate for parametric testing. I'm not sure if
those one they are just some people are very what do I call religious about many things. You know, if you look at the way you judge all the situation whenever something is not normally distributed, there are grades. We say the first one you may rely on the robustness of the test. Then you can proceed to do, you want to do parametric. That's also, let me give an example now. If something is measured on ordinal, and maybe some people now measure different category of that, they now calculate average for a class. You know that something that are made, they have many domains. There are some ordinal scale, like all this quality of life, they have about 5 domains. And there are many questions under each domain. And the way you now, after you have you elicited responses, and these responses are ordinal on ordinal scale for all the questions under a particular domain. To get the aggregate domain, you add everything and divide by the number. You know, the original thing was this was ordinal 1, 2, 3. There's no decimal. But by the time you are calculating average for the group, decimal will come in. And when you have fraction, it become a continuous. That aggregate become continuous for that class, the average for that class, because it can assume any value. It can have decimal. It can be, if the sample size is large, it will be normally distributed. You get the vision now? That is the logic. So there's something like 2 being 3, when something logical. But if it is the original, the way you have scored it, you can be talking of that. Because in that case, they are discrete value. They are, you know, for 94 that is. They both of them on the high side, okay, 94 that is high. So it's the blood pressure then. So is the when you are dealing with that type of is understanding. When you understand the reason, that is why in the research you state all your protocol, what you did, how you did your analysis, how you state them. Anybody that review will be able to reason with it. So it's not a cast system. It's not that it has to be rigid like that. There are some situations where those things will, can be word of like that. That's one of the situations I'm just giving you. And let me even tell you something. Even the original ordinal scale, if the sample size is so large, we talk about the central limit theorem. When it's saying even the sample distribution follow normal distribution. So when you do something and you calculate average, it's like sampling distribution for that for that domain. So somehow fraction will come in. So you can use it. And to prove it, when you run the two, it will give you the same. It will give you virtually the same answer. So what are they saying? Give you virtually the same result. Okay. I'm just trying this one. I'm not saying you have to do that. I'm just trying to use some of those data we use to run non-parametric. Just to try to use them to run parametric. Even when you use parametric for, you can try. That's what I want us to try also. When you use parametric for, you can try. And like this one, when we talk about day loss, even that one say people may say that day loss to say the sample size is very small. A number of day loss is used non-parametric. So that day loss now, I don't know. Let me read it. Or Dr. Malo can read it. Let's use non-parametric to run it. That day loss you did for yesterday. Day loss to abstratism for mining and construction. I don't know if you have the something. Read it and let us use it. Hello? Hello?
I'm
Cannot hear you. Prof, cannot hear you. Oh, Dr. Balogun, help us read that day loss. Let's use to run non-parametric. That day loss that we use for parametric did for yesterday. Day loss to absenteeism or to sickness. I think day loss to sickness. Yes.
I'm trying to locate the file, but
Okay.
satisfaction. I'm just trying. Lost. I don't think.
Okay, maybe I should try and read it myself here. Let me read it. Let me read it from here. Can I read it then? Let me read it here. Let me read it from here. Can we see it? Can we see it? Can we see it? I've shared it. Can we see it? Please, if you don't unmute
Yes, sir, we
yourself,
can see it.
Yes. So you know this is what we use to run the student test, independent sampling. So we can go non-parametric, analyze, non-parametric, legal, two independent sample, day loss, two variable, define.
Oh my God.
1, 2, continue. Let me share the results. Can we see the results?
No.
You cannot see? I've shared now. Can somebody see?
Okay, yeah. Come up.
Yes. Okay. You see my Whitney U? Can you see Wilkinson? All those things? Can you see the p-value? You see, it's significant. So if you look at it, why is the value the other one? This value, the smallest, well, the Wilkinson here is 117. For it to be significant, you have to be the smallest among the two. But if you look at it, how many, what is the sample size? 30. Maybe the critical value for 30 sample size. No, can you see? So if you look at the p-value is significant. And when we run it also with under parametric is significant. So if you run, there's another one, so the other one that talk about the partner and the PRT aspect, PRT test. The one we talk about canceling before and after. Let me read that one also. Canceling before and after. Okay, let me go and read. Let me read it out for you. Bring it out for you. Counseling, hypertension before, no. Anxiety before and after, yeah. It's anxiety. Yes. Let me read the anxiety. Let me bring it out. So we can see it. Can we see the data? Data file. SBC, SAB, SAC. Call before counseling, call after counseling. Can you see?
Yeah.
Yeah. So, you know, yesterday we just go to compare me this. Then you just go. Now let's use the non-parametric counterpart to run the same thing. That's two related samples. So we give you sign and we kissing. Let me share the results. Can you see the output?
Not yet.
Yeah, not yet.
Yeah.
That's come now.
Yeah, the sign. It's come up.
So you see, we can see. Let's see, we can see. Okay, no, now it's significant also. You know, it was significant yesterday also when we run
It's
it.
the sign I'm seeing.
Oh, so I know I'm showing the p-value of the Wilkinson first. Look at the Wilkinson, the p-value. You know, the p-value is 0.17. This is Wilkinson.
Okay.
The sign, the p-value is 0.07.
Yeah.
It's not significant now. Can you see? The sign is not significant.
Yeah.
But the Wilkinson, you know, I've already, that sign is not even median. You know, the sign also is like median test. The sign test like median. It's not powerful. It's not powerful. So if you look at it now, both the parametric and non-parametric, both the student PhD test
Sign.
and Wilkinson, Tyrant, that's non-parametric counterpart are significant. But that sign test is not significant. Almost 0.07. But it's not significant. It's not that sign test is not strong. The examiner is not strong. That is why if you want to use at all, use ransom and sign and Wilkinson, Whitney and Wilkinson test rather than using all those sign median. All those ones, they are not strong. That median is only maybe where you now have sensor data. That's only for survival analysis. That's where you are straight jacketed to use that one. So I think, do you have question? Let's see if you have question on what we have. So that we review what we have done. You see, you review what we have done.
Okay.
You know, the last training we had, with Dwayne Munch, we talk about association between categorical and categorical. Right? Let me just, before categorical output, how will I even put it here? Okay, let me just draw a table. Do you have question? Any question?
Of a platform that makes payments in NTDC. There are different steps to take
Somebody is talking. Somebody is talking where he's disturbing us. It's from that pro. I've muted him. Okay. Are we together, please? Exposure. Can you see what I'm sharing?
Yes, sir.
Yes. I want us to quickly review what we have done. Exposure, outcome, variable, outcome, the bivariate test, bivariate regression, multiple regression. You can use anyway. We cannot even talk about multiple. Okay, so like when the outcome is exposure is categorical, and outcome is categorical. So what do we use? We use chi-square. You remember? That's what we did last time. But when you will see situation where the exposure is categorical also, the outcome is numeric. Or numerical. 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 This is where we use t-test. If there are two categories of this, two categories. Two categories. When you have two categories, is t-test.
What type of t-test? Independent?
Well, don't worry. There's two means. You know, the issue there is that, either independent, you know, when we are actually talking of sample, you know, all the t-tests, they are comparing two means. Even one sample t-test is comparing the sample t-test with the mean in the population. Pair t-test is comparing mean before and after, measurement before and after. The independent just means that the two measurements from two different groups, right? So that's why the logic is still the same. T-test. When you're talking of two means, two means. The why I'm separating is that category can be more than two, but the same logic, the same type of thing you want to do. That is when we are having greater than or equal to 3 categories. We are talking of ANOVA. Analysis of variance. Can we see now? So t-test, the family and their non-parametric counterparts, right? And non-parametric counterparts, all of them have so non-parametric counterpart. These also ANOVA and non-parametric counterparts. So now you may say, okay, what of numerical outcome and categorical exposure, numerical exposure, categorical outcome. So yeah, what of numerical, both of them numerical exposure, numerical outcome. No, that's the way the logical way to think of this.
Are you sharing anything?
Yes, sir. Dr. Balogun, are you not seeing it?
Yes.
I'm with you.
No. We're hearing, but we're not sharing anything.
I'm not sharing any. You cannot see what I'm showing?
No. I can see it and hear you.
Dr. Balogun, can you see?
I can see you. You are typing it out one by one.
Are you seeing you are seeing what I'm typing?
No.
I think I share it now. Okay, let me look at it.
No, we're seeing. We are seeing.
Can't you see the screen? The what are you? I mean, you are seeing the PowerPoint I'm typing.
Oh yes. Yes,
I didn't
now.
put
Yes.
presentation mode. That's why I didn't put it in presentation mode so that I can type on it. So numerical.
It's okay.
Numerical. This is where correlation coming. You understand me now? Correlations, they are here. Though in correlation, they don't even talk about one outcome or one exposure. Just say anyone can be outcome or exposure. So when you are dealing with two numerical variables, so it's not actually you even say one is outcome or exposure, but two numerical variables. Anyone can be outcome or exposure, but you are not actually considering yourself about that. Is two numerical variables is correlation. But when both of them are categorical, it's chi-square. Those are so when we talk about even chi-square, relative risk, all ratio is here. When you collapse the category to 2 by 2. So this category may not necessarily be 2 by 2, but when you want to calculate the all ratio, you must collapse both of them into 2 by 2 to give you 2 by 2 table, right? Those are the things that feature under this, and those are the things we did in the last training. This second row is what we are just done now. So the next one is the ANOVA. Why it's difficult to match ANOVA with this one is that there are a lot of things under ANOVA, because if you do your this is statistically significant. If you have 3 groups, you have to now find out where is the significant. It's another game, core game, where you'll be talking of post-hoc test or plan contrast. But with the look of it, what I would do is that the training on ANOVA, I will try and match up with correlation, so that the ANOVA the correlation is more related to regression. But the funny thing also, the ANOVA and regression is the same thing. You get the picture now. So
sure.
Now, you ask me here, there's no bivariate statistic to do this. Outcome categorical, this one. So unless you get to regression. Yes or no? Like this one now, logistic regression. This one is logistic regression. Whenever outcome is anywhere you see outcome categorical, is logistic regression. I don't need to put multiple yourself. Anywhere you see outcome categorical, all I even need to say is just say regression. I don't even need to say this one. Just say regression. Let me just say, because regression can be bivariate or multivariate. Thank you, multivariable. Thank you. It's not multivariate, it's multivariable, bivariate or multivariable. Whenever, okay, let's just put it there. Multivariable regression, bivariate regression. This is bivariate regression, the multivariable. Multivariable means that the outcome is usually one, but the exposure is many. So look at this one now. Apart from this chi-square, you can do regression here. And the logistic regression can have 2 possible outcome, 2 category of outcome. Or you can have 3. Binary, logistic for 2, multinomial for more than 2. Even it can be ordinal, that is the outcome can be ordinal, can be in category, like a socioeconomic status now. If socioeconomic is an outcome of something, in that case, higher, middle, lower is ordinal logistic regression. You used to analyze that type of thing. There are more than 2 categories and it's in order, ordinal. So logistic. Now when here now is linear regression. Since the outcome is numerical, and you see now?
Numerical.
Yeah. It's linear regression. Here, the regression you do here is linear also, because the outcome is numerical. Yes, since this one is linear also, if you want to do anything here. So you see, the regression, the type of regression you do is a function of the outcome, the type of outcome variable. When your outcome variable is categorical, is logistic. When your outcome variable is numerical, is linear. Are we together? Though the regression, okay, the correlation, okay, I think another problem. This correlation has different type. Though here the correlation here is dicey because the correlation can be linear correlation, Pearson correlation, which is linear, and Spearman. When the thing is ranked, like if it is categorical that is ranked, like all this ordinal, is Spearman correlation. Just know that when your outcome is numerical, it's linear regression. So you see,
yes.
Here now, the way you can see is that if your category, you have a categorical outcome, for you to do chi-square, you have to change it numerical category. That's what people do. You now categorize it like age now. You split it into category, age group. Whatever you now divide, range it into group. That is the only thing that can make you to now use chi-square to test this place. But in logistic regression, the exposure variable you can feed in numerical directly. Just like in linear regression, you can feed in categorical something. The only thing you can have to, if you want to use categorical for regression, either linear or logistic, you have to code it. You have to do create dummy variable. You will see, if you notice, in some of the file I give you, like this one I run now on Libido, you see dummy I created here. Because I use it to run, I use for regression. I used to do linear regression. Because that dose, placebo, low dose, they are categorical. If for me to use to run regression, I have to create a dummy variable. And when we get there, we'll talk about how to create that dummy variable. So I just want us to have the understanding. Like now, in the last training we did is on this first line. Though we have not done regression, we didn't do it, we have covered this. And this training, we cover this. The next thing I want to do is to cover Ada ANOVA. ANOVA, I will see if ANOVA alone cannot take that, so I would say if I can put correlation also. ANOVA and correlation together in that training. So that when you now get to the next one, we now know that linear regression. Do linear regression, not do logistic regression. If it's not possible to combine linear and logistic in one thing, so if by the time you do that, so what is telling us is 1 or 2 training, let's say 2 training or 3, yes, I think maybe 2, will cover almost everything, except the only one that has special training on what do I call it? Like diagnosis test, sensitivity, specificity, reliability. That's all. There's a different reliability, different type of reliability, how to run it. On especially also how to run reliability, kappas, all those stuff, and Chromback alpha, all those, how to do validity, all this validity too. Though the validity is very funny. It's under some validity once you know how to do t-test, or it's just for you to know when to do it. With the t-test, you even use to do some validity. You know, like all those you want to do discriminant validity, all those validity is all those other statistics you have done. You know how to that is things you want to do. Like diagnosis test itself is a form of validity. You know that because it's talking about sensitivity and specificity. So it's a criterion validity. Diagnosis test is a special form of it's a criterion validity. So those ones are special training. But all these ones you discover that running data, then the multiple regression. What this one just means that multiple regression, which is multivariable. The exposure is one, the outcome can be many. And you know that the outcome can be, it doesn't really matter. Even in logistic regression, multiple or single, the exposure can be numerical and be categorical. Even in linear regression, the exposure can be numerical or categorical. But what makes linear different from simple is the type of the outcome. Either it's a quantitative outcome or categorical outcome. I don't know if you have questions. And try to review what also. Yes?
It's been very, very interesting. Actually providing an insight into how you can apply logistics regression and linear regression. I mean, for the very first time, I'm grabbing the concept because sometimes you confuse the two.
Yeah.
So that's why. So most times, from what you've said now, there are instances when you get to numerical variable. So when you don't have an appropriate statistical test to compare,
yeah.
So we have to transform to a particular one, maybe age to young, middle, old, or things like that, to allow us to run the chi-square analysis. Is that what you mean?
Yes. What is not if you look at this second to the last row, whenever the outcome, maybe the outcome you are measuring is categorical. Maybe you have already said anemic, not anemic, an outcome, right? The factors you are looking at, they come in different form. Can be age, can be sex, many other factor that can contribute, nutritional, all those stuff, that can contribute to anemia, which you have already categorized. So anemia is if it's hemoglobin concentration, is numerical, but you have already categorized it. You want to know using the standard cutoff to differentiate anemic from anemic, not anemic. In that case, your outcome is already categorical. Anemia, anemic, yes or no. But you see that those factors you want to see, they influence anemia. They are there. Some of them come as categorical, like sex, like socioeconomic status or whatever. Then some come as quantitative, like numerical. Age. Numerical, like age, like many other things. So, before you can do regression, it's from all this initial analysis. I don't know if you understand me now. All this initial analysis that is between category, like now, this outcome, if anemic, non anemic is categorical. Any other thing that is categorical there, you just use chi-square to run the relationship first. You really know what is there before you can. So you do it for the bed. For this one that is numerical, what you can do for it is to have a cutoff point for it, like age. Now you now have your age range less than 20 to this, and now do your age range. By doing the age group, that age group says categorical. You'll be able to now do the association before we now move to logistics. But when you now learn, you know, since it's categorical, outcome categorical, regression you're going to do is logistic. In doing that logistic now, you don't need to use the age group you did. You can run the age directly, even though when you were trying to do chi-square here, you categorize the age. But the age, you can run it directly when it comes to regression. You understand another time you can. So the linear regression also, you can feed in anything, both categorical and non-categorical. But the only thing that whenever you want to use a categorical or regression, you have to create a dummy for it. Even either it's linear or logistic. Even the logistic that is for categorical, you must create a dummy. Yes, I mean now. The way we enter it is different. It's going to be 1, 0, 1, 0. You will not code, even when you have coded something 1 or 2. When you want to learn in logistics, you have to run it at 1-0. That's computer language, run 1-0. One is there, it's not there. No, that is the logic. Yes, I'm now. So because the logistic is by arrangement, is by permutation. Yes, I'm now. The way the computer do is rearranging it. It's permutation, it's by permutation. So you have to create a dummy to assign 0 and 1. But when we get there, we see it's very simple how to create a dummy. When you have 2 categories, you create 1 dummy. When you have 3 categories, you create 2 dummies. So the number of dummy you create is the number of category minus 1. Because you're going to hold 1 category constant while you create dummy for the other one. So that's the way it works. So it's something that is very, when you get there, you see the logic behind it. I don't know if there's any concern, any other concern. Any other concern?
None for today.
Dr. Kayode? Dr. Kayode?
So they don't sleep. Or...
Maybe you don't sleep. Unmute yourself. If you are talking, you unmute yourself, we cannot hear you. Dr. Kayode? Unmute yourself. Yes, I say you have question. No question. I'm not hearing you. You are muted.
Hello, sir.
Yes.
No, sir.
Okay, that's great.
Yes, sir.
So I think if there's no question, we can. So let's review. Have we learned something in this series?
Yes, sir.
I want your opinion, because all of you are part of the categorical. I am of the opinion that the quantitative is easier to conceptualize than the categorical. Is it true? Is this one we did this time easier to conceptualize than the last one we did? Hello?
I think both are okay.
Sir?
Both of them are okay.
No one is easier than the other. I know both of them are okay, but which one is easier?
Okay, the first one is easier than this one.
And
I think the first one is most straightforward. All those quantitative ones.
No, I'm not talking of, I know quantitative is most straightforward. I'm talking of the last one we did on chi-square, different type of chi-square, the last training we did that last weekend or 2 weekends ago. Comparing with this one, I'm not talking of parametric and non-parametric now.
Okay.
I'm talking of the training on this one. We dwell on chi-square, and this one we dwell on t-test. Which one is easier to conceptualize? Dr. Larry?
T-test is easier.
T-test, yes, I agree with you.
We can say that all those ones that will rank figures and you'll be finding the difference. We need to really take time to understand.
Okay, no, you have not got what I'm saying. I know that t-test is easier than all this non-parametric. I'm talking of the t-test and the chi-square. Which one is easier to conceptualize?
Chi-square. The chi-square was more detailed. Lecture was
okay, the lecture was more detailed than this.
Yes.
Okay.
Well, I think another reason is that most of the time what we use is chi-square. So
yeah,
I think
people are more familiar with chi-square.
Yes.
Because if you look at the logic behind hypothesis testing, it's this test that gives you the understanding more. The logic behind hypothesis testing is the t-test that gives you an understanding. Even all those other, I know that all this not parametric, including chi-square. Chi-square is not parametric. It's adaptation of all this understanding of the numerical, this t-test that they actually use. It's adaptation. So, but I think because chi-square, people are more familiar with it. And what also makes this one to be more somehow is this issue of, it's not with the t-test now, it's this issue of non-parametric. So as I've said, so the next one, all of you can be part of it, because I will have to work more on the non-parametric aspect to make it understandable. You guys understand now? Because if when I'm giving the type of question people ask, I know if people understand or not. You get the picture now, the type of question people and the way people flow. I know that people easily flow. When we treated the teachers, it was more straightforward. But when it comes to all these non-parametric that has no basis for, so I will try to look for better way to break it down for people to understand. Maybe by the time I do the next one, the next weekend, and that's why I want you to be part of it. So maybe it will make more sense for you. At least it will be advantage for you because you have heard of it before. I don't know if there's any other thing. Hello?
All right. Thank you very much, sir.
Thank you. So we can call it a day.
All right. Good night,
We
sir.
achieve our objective.
Good night.
Yes. Good night, sir.
Yes, sir, but I hope you send us the slides.
I will do that. I will do that.
Sir. Thank you very much.
And the video, right? Okay, thank you. Thank you, sir. Good night.
All right. Thank you, sir. Good night, sir.
Thank you, sir.
Good night, sir.
Yes, sir.
Good night, sir. Femia.
I don't know how